All right, let's jump right in. We're talking about decoding finance, and we're going to build your essential equation toolkit. Ever stop and think about how a massive company decides to drop, say, $1 billion on something? It's not just a gut feeling, that's for sure. It all comes down to a handful of powerful equations, a kind of toolkit for making incredibly smart financial moves. And today, that's exactly what we're going to do. We're going to decode that toolkit piece by piece. So, how does a company actually decide to spend $1 billion? I mean, it sounds impossibly complex, doesn't it? But here's the thing. Whether they're building a brand new factory or launching the next big thing, these huge decisions really boil down to answering just a few key questions. And they do it with some surprisingly elegant math. Let's dig in and see how it works. Okay, first things first, we've got to talk about finance's golden rule. This is the big one. It's the simple idea of why a pound today is not the same as a pound tomorrow. Seriously, this concept is the bedrock, the foundation on which everything else in finance is built. And it all comes down to the value of time. So let's talk about the time value of money. The core principle is that money you have right now is worth more than the exact same amount of money in the future. So why is that? Well, think about it. For one, we'd all rather have stuff sooner rather than later, right? That's just human nature. Then there's inflation, that sneaky thing that means a pound in the future just won't buy as much as it does today. And of course, there's risk. A promise of money later isn't a guarantee you'll actually get it. But honestly, the biggest reason of all is opportunity. If you have that money now, you can invest it, you can make it grow, and that potential earning power is what gives time its value in finance. All right. So if a pound today and a pound next year are two different things, how on earth do we compare them? How do we make an apples-to-apples comparison? Well, what we need is a way to value money across time. We need a financial time machine, if you will. And lucky for us, we have the formulas for that. This is where our first tools come into play, present and future value. Yeah, so this financial time machine, it can go in two directions. On one hand, you have compounding. That's all about converting today's cash into what it could be worth in the future. It's like looking forward in time. But on the other hand, you have discounting. And this one is key for making investment decisions. Discounting does the opposite. It takes some future amount of cash and tells you what it's worth in the present. It answers that absolutely critical question, what is that promise of future money actually worth to me right here, today? And this right here is the engine of that time machine. This is the present value formula. Now I know, it might look a little intimidating with all the letters and symbols, but trust me, it's incredibly powerful and actually pretty straightforward once you see what each part does. So let's break it down. Okay, let's pull this formula apart. First up, PV is what we're trying to find, the present value, what that future money is worth today. Now FV, that's the easy one, that's the future value, the actual cash you're expecting to get down the road. N is just the number of periods, basically how long you have to wait. Usually we think of it in years. And then there's I. This is the secret sauce. It's the discount rate. The best way to think about I is as your opportunity cost. It's the return you could be getting somewhere else with similar risk. You put all those pieces together and boom, it tells you the present value of that future cash. So let's see this in action. Imagine you're promised £5,000 a year for the next 4 years, and your discount rate is 5%. Now, you can't just say, oh, that's £20,000. No, you have to discount each of those future payments back to today. And look at this table. You can really see the power of time at work. That $5,000 you get in year one, it's worth about $4,700 today. But the same $5,000 you have to wait 4 years for, it's only worth about $4,100. That's a big difference. So when you add up the present value of each of those individual years, you get the real value of this entire deal today, £17,729. Okay, great. So now we have a tool to figure out what a future pile of cash is worth today. But that's only half the battle, right? Knowing what it's worth is one thing, but the next logical question is it a good deal? Should I do it? For that, we need to bring in the ultimate decision-making tool in finance. And that tool brings us to maybe the most important decision rule in all of corporate finance. And it is beautifully simple. If the net present value, or NPV, is greater than or equal to 0, you accept the project. You say yes. That's it. If it's positive, you do it. If it's negative, you walk away. A positive NPV means the investment is expected to create more value than it costs. Simple as that. And the formula for NPV is just as straightforward. All it is the present value of all the cash you're going to get, the inflows, minus the present value of all the cash you have to spend, the outflows. Usually that outflow is just the upfront cost of the investment. It's really just value of what you get minus value of what you give. So let's go back to our example and make a decision. We already did the hard work, right? We calculated that the present value of all the cash coming in is £17,729. Now, let's say this whole thing costs £12,000 to get started today. That's our cash outflow. So to find the net present value, we just subtract that cost from the value of the inflows. And there it is. We get a positive net present value of £5,729. This is the magic number. This is the number that drives the decision. What it's telling us is that after covering all our costs and after accounting for the time value of money, this project is expected to boost the company's value by over £5,700. The decision? It's a clear, confident go. But wait a second. You're probably asking a really smart question right now. In our example, we just used a 5% discount rate. Where did that number come from? For a huge corporation, where does that I value really come from? Well, you're right. In the real world, it's not just pulled out of thin air. We need a way to calculate the project's hurdle. And to do that, we need to find the discount rate using something called WACC. It represents the company's actual real-world cost of getting its hands on money.
See, any company has a certain capital structure. It basically gets its money from two places. One slice of the pie is equity. That's money from shareholders, the owners of the company. The other slice is debt. That's money it borrows from lenders, like banks. Now, both of these sources have a cost attached, and to find our true discount rate, we need to figure out the blended or weighted average cost of all that capital.
And the formula we use for that is the weighted average cost of capital, or WACC for short. Again, looks a bit complex, but the idea is simple. You just take the cost of equity, multiply it by how much equity you use. Then you take the cost of debt, multiply it by how much debt you use, and add them together. Let's make this really concrete with an example. Okay, let's just walk through the steps. First, let's find the weight and cost of the equity. Let's say equity is 80% of the company's capital, and shareholders expect a 12% return on their investment. So we multiply 80% by 12%, and we get 9.6%. That's the weighted cost of equity. Now let's do the same for debt. Let's say debt is the other 20%, and the lenders charge an 8% interest rate. So 20% of 8% gives us a weighted cost of debt of 1.6%. The final step? You just add them together.
And just like that, you get a WACC of 11.2%. So what is this number? This is the company's average cost for every single pound it puts to work. This is what's known as the hurdle rate. Think of it like a high jump bar. Any new project the company considers has to promise a return that can clear that 11.2% hurdle. If it can't, it's not worth doing. So this is the specific calculated discount rate, the I, that a real company would plug into all those PV and NPV formulas we just talked about.
And there you have it. You now have your new financial toolkit. We've just put together a super powerful set of tools that takes you all the way from a basic concept right through to making a final, smart investment decision. So let's quickly recap what's in your new toolkit and the questions each tool answers. First, the time value of money, using present and future value. That answers, what is money across time actually worth? Second, net present value, or NPV. That answers the big one. Is this investment a good deal? And third, the weighted average cost of capital, or WACC. That tells us, what is our minimum acceptable return, our hurdle rate? There's a famous quote, often attributed to Albert Einstein, that just nails why all of this is so important. He said, "Compound interest is the most powerful force in the universe. He who understands it earns it. He who doesn't pays it." And that's really it. Understanding how value is measured and how it grows over time is the absolute key. So, now that you have the tools, what value will you decide to create? Because here's the secret. These equations aren't just for giant corporations. They're a way of thinking. They're a framework for making smarter decisions in your own life, with your own money. So, the only question left is, what will you build with them?